Hi students, today we are going to see a new topic. The topic name is electric flux. Little idea you have about the term flux because in grade 10 lesson there was magnetic flux. That is simple way we can say like how many lines, how many magnetic field lines are there in unit area, that is magnetic flux. Here also almost the same concept. Here it is electric flux, we call the name, that is electric flux over an area is an electric field represents total number of electric field lines. Okay, total number of electric field lines passing through a given area we can say. So electric flux over an area in an electric field represents the total number of electric field lines crossing through a given area. And the symbol to represent the electric flux is phi. This read as phi. Okay, let me finish this one. Okay, area normally you see a word normally meaning is perpendicular to the surface it is. Okay, and you know that area vector is always normal means perpendicular to the surface. So the electric flux phi through an area, electric flux phi through an area element. Remember when we write the expression, always look into the angle value. Which angle value? The direction of field lines and the area vector. That is an important fact decider. Okay. The electric flux through an area element delta S. Why delta S is considered? Because right now we are talking about the small area. Delta S in an electric field E is defined as per the definition, okay, delta F is equal to E dot delta S. Remember this is in vector form now, okay, vector form, E dot delta S. In scalar form we can write this one is E delta S cos theta, okay. Delta phi, because we are considering small area element delta S, so delta phi is equal to E dot delta S in vector form or E delta S cos theta. Okay, that's all. Now what is theta actually? Theta is the angle between, there are two variables, right? One is the electric field and another one is the area vector. Okay, so theta is the angle between E and delta S. So remember the value of theta, that is theta 0 is the highest value because cos 0 is equal to 1. If angle between them is 90 degree, no flux exists. For theta is the angle between E and delta S. You can see the diagram to understand more. Okay, that angle between them. See the unit vector direction, that is the area vector. This is for uniform area, okay, uniform electric field. Sorry, uniform area. For non-uniform surface, better to take the integral form. This is for plain clean area, E dot delta S is equal to E delta S cos theta is fine. Okay, but for non-uniform surface, total electric flux we can write like this one, phi is equal to, you remember this symbol, yeah, integral, that is closed integral vector E dot ds, okay, ds smaller, so is equal to integral, that is closed integral E ds cos theta. This is the way to use for non-uniform surface, and the first equation is used for uniform surface. Okay, and what I am writing now is, you can see a new symbol on the integration. One circle you can see, a small circle. What is that meaning is, the circle on the integral sign indicates that, and because of some students are not specialized in maths, they will feel like what is this one, never seen before. So that indicates that surface is a special type of surface, not open surface, that is a closed surface. Okay, that is a closed surface. That is the meaning of that one. So the circle on the integral sign indicates that the surface of integration is the closed surface, suitable for closed surface integration. and see a new point here just to remember the points. What is that point is? What type of quantity it is? The electric flux. Electric flux is a scalar quantity. Because of the E exists there, don't think that that is a vector quantity. This is a scalar quantity. Possible in MCQ question. Remember it, okay? Another one point I can write here. First point is to remember is electric flux is a scalar quantity. And the second one, getting ready. So overall the topic is easy, right? This is the base of this area, where after this will go to the next level, that is one Gauss's theorem is there, that is also to calculate the flux. Okay, so for a closed surface, the flux comes outside from the surface is taken as, there will be positive negative concept, right? Positive, this one. The flux, when will be the flux is positive, that is for closed surface, the flux comes outside from this surface is taken as positive. That meaning is flux is coming out of the surface. And suppose in the diagram or in situation where flux is entering into the surface, that is going inside the surface, what you can say consider is that flux is a negative. So the 2 points to remember here is, one is electric flux is a scalar quantity. Second thing is the flux coming out of the surface is considered as negative, and the flux coming out of, or the flux going inside the surface is considered as negative. Okay, that's all. So that is the knowledge about what is the electric flux. You can refer this diagram also, like how will be the direction of the flux. Going outside from the body, positive flux, coming into the flux into the body, considered as negative. Now we can have a numerical now related to this. The electric field in a certain region of space is 5I plus 4J minus 4K into 10 raised to 5 Newton per Coulomb. Calculate the electric flux due to this field area. So field over an area of 2I minus j into 10 raised to minus 2 meter square. So note down what is given here is, first one I underlined electric field given, second area is given. Remember, we have to do this using the vector product. You studied, right? Vector product, grade 11 there was a lesson, work, power and energy. In that lesson, this was explained, how to do the calculation for vector. So first, whenever you see a numerical, your first responsibility is note down or write it, what are the topics, variables given in the question. In this question given, E is equal to given. So 5I plus 4J minus 4K into 10 raised to 5. Okay, close the bracket, into 10 raised to 5 Newton per Coulomb. Newton per Coulomb, that is electric field unit. Okay. Next you write the area. Area also given, right? So area, right? When you write area, you will notice that there are usually expected 3 part in the vector ijk components, but here I and j component exist, k component not there. Okay, some people write this one is plus 0k format. Okay, so here ds is equal to, or delta s also you can write, okay, 2I minus j into 10 raised to minus 2 meter square. Next we can do like this one. We know that the equation for flux calculation, you know, right, that we can write. Now only we saw this one, before this topic we saw. So we know that the electric flux, the symbol to represent the electric flux is phi. So we can write like a electric flux phi is equal to vector E dot delta S. Okay. Now we are going to do that one. You studied, I assume. If not studied, no problem. This may be your first place to study. Very easy way we can solve this one. I will help you to solve this one. Okay. Don't worry about how to manage this one. Remember, whenever we do one numerical, consider that is actually a sampling. Do not expect that exactly same question will be asked, but you can expect a similar question. So first thing is substitute the value of E and ds, that I am doing now. So 5i plus 4j minus 4k into 10 raised to 5 dot 2i minus j plus 0k. If you want, you can write, otherwise leave it, into 10 raised to minus 2. Now you need to remember some basic things in vector part. Okay, what is the basic part is, in dot product, I dot I, j dot j, k dot k, only this type multiplication exists. Same vector multiplication exists. So wherever you see a term like 5i into 4i or 2i exists, the term like I dot j or j dot k or k dot I is equal to 0. Even it can be j dot I, reverse also fine, k dot j and I dot k, all will be 0. So only what is exist is same dot product exist. So look into the question now, we work on that one. Identity or the method to follow I explained. Same dot product exists and I into j or k does not exist. So start writing. Okay, you know that multiplication, right? First term of the E, that is 5i dot, first term of the ds 2i, plus first term 5i dot minus j, first term of the E, into second term of the second, that is ds. Then first term of the E, first one E, into third part of, that is k component of the ds. Remember, there is no third component given in this question, so dummy I applied 0k. That finish, first part finish, that is multiplication of first term of E to other ds components finish. Next, second going on now. Second component of E is plus 4j, j component, plus 4j dot 2i plus 4j dot minus j plus 4j dot 0k. Now you got idea, right? What will exist, what will not, what will vanish. Now first term into third one. Now start again. Minus 4k, that is from E, okay, in dot 2i plus minus 4k dot minus j plus minus 4k dot 0k. Can you identify what exists, what vanish? Why I am keeping a unit vector, square bracket now? Because actually along with E there was a 10 raised to 5. Along with the ds there was a 10 raised to minus 2. Okay, that we will apply the exponents rule, no tension. Now we mark it, what exists, what does not. The first term exists or not? What do you feel? I dot I exists, right? So I gave a tick mark. Exists. Exists meaning is I dot I, answer is 1. Exists. Now I dot j does not exist. The reason is I dot j, no, the answer is 0. I dot 0k, anyway I dot k itself it is 0, no need to look into coefficient of k. Now 4j dot 2i, no exist because j dot I. 4j dot minus j, yes exist, I gave a tick mark. Okay, third one, no exist. Now come to the third part. Minus 4k dot 2i, no exist, right? Minus 4k dot minus j, no exist. Last part actually exists, but because of 0k, actually that term not there in the question. If there was term, definitely that will be considered in the calculation. Now 10 raised to plus 5 into 10 raised to minus 2, answer is a raised to m into a raised to n is a raised to m plus n format, right? So it will be 10 raised to plus 5 minus 2, 10 raised to 3. When time comes, we will do. Now the answer writing now. The first part exists, 5 into 2 is 10, 10 into 1 is 10. Plus, then second 4j into minus j, we expect that is minus answer because one is positive, one is negative, minus 4. Third one, no exist in this question, so not writing. Then 10 raised to 5 minus 2. So flux is equal to, going to answer now, complete now. 10 minus 4 is the value given. Yeah, 10 minus 4 into 10 raised to 3. So we are finished now. We will write the final answer. 5 is equal to 10 minus 4, that is 6 into 10 raised to 3. Better to note down the unit also nearby the flux. So Newton meter square per coulomb. Okay, that is the end of this numerical. This topic is actually a small topic, and one numerical also explained. Okay, how is this one? Is it okay? If you like the explanation, please share with your friends. Especially there are so many students struggling to understand physics. In your class there will be many students. Just share the link. It will be a great help for me and your friend. Okay students, thank you. Have a nice day. Bye bye.